Okay, here's another one that we can practice. Again, if you first notice this, you'll notice that it's not quite in the form that we like. We don't like to have it with the 2 inside the brackets here. We want it outside the brackets, but still within the function. So it's got to sort of pop out here. In order to make it pop out there, though, you got to divide both of the things by 1/2. By 2. So we like to have it out front like this, still within the function because it's still part of the sign, but at least it's outside those little brackets. So we got to divide each of them by 2. That's easy to do here, dividing this by 2. But the fraction is usually where people make mistakes. So we need to divide the fraction by 2. Well, what's 1/2 or pi over 2 divided by 2? Well, that's 1/4. So pi over 4. It's a half of a half, and a half of a half is a quarter. Again, you can always verify that you've done this right by rainbowing back. Rainbow this back, and it would be 2 theta plus 2 pi over 4, which is 2 theta plus pi over 2, and that's what we wanted. Okay, so that's a little check that you can do to make sure that you brought out the 2 appropriately. I'm just going to get rid of that so we have some space. All right, so this is what we need to sketch. Write down all the information about it. I think on this one I will say that the amplitude is the number in front is 1/2. This is sine, by the way, so that's good news. There's a 2 here, so that's going to affect the period. It's within the function, so it's opposite to what I think. I see a 2. That's going to make it smaller. So the period's going to happen faster. It's going to happen twice as fast. Normally a period is 2 pi, but this one is going to happen twice as fast, so I got to divide it by 2, and it's only going to be pi. I can also use the formula 2 pi over k. The k is 2, so it's 2 pi over 2. And I see the period is pi. So that's what I expected. Then I use this. It's a positive, so it moves left. So the phase shift is left, pi over 4. Again, noticing that it's become pi over 4 because I had to bring that 2 out, not pi over 2. And then the last part is the plus 2, which affects the vertical translation. And it's moved up 2. So there's all my information. Again, I'm going to take this to choose an appropriate scale. Probably won't be the same as the last one because I got lots of different things happening. The period is much shorter. Okay, so it's a half, so I have some luxury there. Also, I'm going to eventually need to move it 1/4. So I'm not going to do 6ths here because that's going to be a little challenging to do it in quarters. I think I'll do it in quarters. So I'm going to go 1/4, 2/4, 3/4, 4/4, which is pi. 1, 2, 3, 4, 2 pi. 1, 2, 3, 4, 3 pi. So it's going to be moving quarters, so that's good. I can actually go into the negatives and make this negative pi if I want it. Secondly, I got to choose an appropriate scale to consider the amplitude and that it's been moved up 2. So I think like with the last question, I got to make sure I have enough room to move up 2. I think with an amplitude of a half, I should be able to do a scale of a half. So a half, 1, a half, 2, a half, 3. Similarly in the negatives, -1, -2, -3. Okay, so I'm going to start by drawing my original in this scale. So it's the sine function. I'm really good at the sine function. Starts at 0, ends at 0, halfway it's at 0. Halfway between 0 and pi, it's at its maximum, which is 1. Halfway between pi and 2 pi is at its minimum, which is -1. This is the original. The original sine curve. Sketch that lightly in pencil. Then I'm going to do all the translations on that. Again, I'm going to do my phase shift, my amplitude and period change first. Okay, you may choose to do this in 2 steps. The last one we didn't have a period change, so we just do the amplitude, but this one has both. I think we can do both at once, especially on the sine function. So the sine function starts here at 0, and it finishes now, because the period is pi, it's going to be finished at pi. That means it's going to go back to 0 at pi. So if it starts here and finishes here, halfway it must be back at 0, because that's what the sine curve does. Then I'm going to take halfway between the first two, it's at its maximum. The maximum used to be 1, but I notice now that the maximum is 1/2. Right? There it is, 1/2. So halfway between these, I'm going to go to my maximum, which is 1/2. And halfway between these two, I'm going to go to my minimum, which is negative 1/2. And I'm going to sketch my curve. Lightly and in pencil. That is the one that has an amplitude of 1/2, and the period is only pi. Now that graph is going to move. It's going to move left and up. So it's going to move left pi/4, which is 1 tick. And this is going to move up 2. So that means 4 ticks, right? We look at our scale. 1, 2, 3, 4 ticks is an up 2. So my green graph's got to move up 4 ticks and then 1 tick to the left. You can either do it left first and up 2. There it is. Or you can do up 2 and left pi/4. Either way, we get to the same spot. I'm going to lose those so they're out of the graph. And just get that. Then my finishing point is going to move left and up. Again, I'm not going to actually have that on there. I'm going to just do it with my fingers and get there. I can also check that my period is the same. So I'm looking at the green graph. If I count the green graph, I go 1, 2, 3, 4 ticks. So my red one should go 1, 2, 3, 4 ticks. Good, it does. So my period is correct. All right, halfway between these two is back to 0. So I know that, or I can count this over and up. Then halfway between the first two, I'm at my maximum. My maximum is 1/2. Halfway between these two, it's at my minimum, which is negative 1/2. And then I have my final picture. And this is y equals 1/2 sine 2 theta minus, or sorry, plus pi/2 plus 2. I don't care whether you write it in the original question or the adjusted one. Either way, there's our answer. So hopefully this has been a nice little review and you've had lots of practice. Now I want to see you actually try it in your assignment.